If your basement in Indiana floods tonight, you might actually be surprised to learn that you can blame a cloudless, like 105-degree afternoon down in Texas.
Oh, absolutely. Yeah.
Because, when you open up a weather app on your phone, you usually just see this localized snapshot.
Right. Just your city.
Exactly. Like a sun icon over your town, maybe a rain cloud, a couple of numbers, and it feels completely disconnected. But when you zoom out to the continental scale, that simple map just vanishes.
It really does.
You aren't just looking at local temperatures anymore. You're looking at the intricate blueprint of this colossal, invisible atmospheric machine.
Yeah, and it really operates like a massive engine. I mean, all those seemingly isolated numbers you see on your phone, they're actually gears turning each other.
Just grinding away.
Exactly. And sometimes they're thousands of miles apart. So a shift in air pressure in one time zone, well, it inevitably forces a pretty violent reaction in another.
Welcome to today's deep dive. We are analyzing a really comprehensive weather briefing today from the Daily Tech Reader, and this is dated August 13th, 2026.
And this is a big one.
Oh, it's huge. This isn't just a single source. It's this massive aggregation of data from NOAA, the National Weather Service, the Weather Prediction Center, and AccuWeather.
It's basically the heavy hitters of meteorology.
Right. Okay, let's unpack this because our mission today is to move past those simple icons on your screen. We want to uncover the invisible systems that are driving today's extremes.
And really show you exactly how the weather outside your window is directly dictated by this atmospheric gridlock happening across the entire continent.
Exactly. So to give you a high-level synthesis of this August 13th data, the entire continental U.S. is currently just paralyzed by one core meteorological conflict.
Yeah, the country is essentially ripped in half right now.
Yeah.
In the south, you have this relentless, stagnant heat dome that just refuses to budge. I mean, it is locked in.
Just totally parked there.
Right. And in the north, well, because that heat dome is acting like this invisible brick wall, you have a really messy, blocked collision zone.
Where all the passing weather systems are just crashing into each other.
Exactly, crashing and piling up.
So let's start by looking at that dominant feature, right? The engine controlling the entire board right now, which is that heat dome across the southern tier.
Yeah, the briefing describes it as a broad and persistent upper-level ridge.
And rather than just listing off cities, let's look at the sheer scale of the misery here. The entire central and southern plains stretching right through the southeast, they are locked in this punishing heat wave.
It's brutal.
In the humid regions, places like Baton Rouge and New Orleans, they're sitting in the mid-90s. But with that heavy Gulf moisture, the heat indices, what it actually feels like to the human body.
The miserable part, basically.
Right, exactly. Those are pushing into that dangerous 105 to 115 degree range.
Wow. And, as you move west into Texas and Oklahoma, the moisture drops off, but the raw temperature just spikes.
Yeah, Dallas and Fort Worth are breaching 100 to 102 degrees, with heat indices right around 107.
But the critical variable out there is the wind. It's very dry and breezy, which completely alters the threat profile.
Right, because now it's not just the heat.
Exactly. Instead of just a human health hazard, you have an elevated grass fire threat. And this is particularly sweeping up the I-35 corridor.
And then you cross over into the desert Southwest, and the numbers start to look like they belong on a different planet.
Yeah, they really do.
We are looking at a broad regional baseline that is 10 to 15 degrees above normal. I mean, Phoenix is at 110, Yuma's hitting 112.
Ouch.
Lake Havasu is baking at 113.
Yeah.
And Clark County authorities, they've actually been forced to open emergency cooling stations because Las Vegas is hitting 109.
Which is dangerous for anyone out in it.
Completely. But here's the specific detail that makes me stop and really question what's happening. Las Vegas is in the desert, right?
Right.
And deserts are famous for shedding their heat the second the sun goes down. Yet the overnight lows in Vegas are only dropping into the low 90s.
Barely a drop at all.
So it's like a lid on a boiling pot. Are they getting absolutely no relief at 2 a.m. because of this lid effect?
What's fascinating here is the actual physical mechanism of that upper-level ridge. When meteorologists talk about a high-pressure system or a ridge, they're describing a massive column of sinking air in the atmosphere.
Okay, sinking air.
Right. The air is physically plunging toward the ground, and as that air sinks, it compresses.
Oh, yeah.
If you've ever used like a manual bicycle pump and you felt the metal cylinder get hot in your hands as you compress the air inside it.
Oh, yeah, it gets really warm.
Yeah, you've experienced adiabatic heating. The exact same physics apply to the atmosphere. This invisible dome isn't just trapping existing heat, it is actively generating new heat by pushing down and compressing the atmosphere.
Wow, that makes perfect sense. So the atmosphere is essentially doing physical work on the air mass, turning the entire Southwest into a pressure cooker.
Precisely that. And because this massive column of air is sinking, it completely prevents surface moisture from evaporating and rising up to form clouds.
So no clouds, no relief.
No clouds means zero shade. The solar radiation just beats down on the desert floor unmitigated all day long.
And the ground just absorbs it all.
Yeah, the asphalt, the rocks, the buildings, they just soak up that energy. Then the sun goes down. The ground tries to release that heat back into space as long-wave radiation.
But the lid is still there.
Exactly. That sinking high-pressure column is still sitting there, acting as a physical lid. The heat simply has nowhere to disperse.
That sounds miserable.
It is. The air stagnates, and that is exactly why a desert city like Vegas stays at 93 degrees in the middle of the night.
And I imagine that same high-pressure wall also physically repels any, cooler weather fronts that might try to sweep down from Canada to bring relief.
Oh, yeah. It acts as an atmospheric bouncer.
An atmospheric bouncer, I love that.
Yeah. In fact, the Weather Prediction Center is actually flagging potential record-tying or breaking temperatures for the upcoming week, specifically because this ridge is strengthening its grip.
It's digging in.
It's expanding its footprint, and it is just refusing to let any external air masses penetrate its borders.
Which brings us to the cascading effects on the rest of the map. Because this massive southern heat dome is doing way more than just baking Texas and Nevada.
Like we said, it's a brick wall.
Right. The atmosphere always wants to find a balance, right? Cold air naturally wants to push south, and hot air wants to drift north.
That's the normal flow.
But because the hot air is completely entrenched, that cold northern air hits a wall, and it creates this violent collision zone stretching across the northern and eastern parts of the country.
Yeah, it completely disrupts the normal flow of the jet stream, which is, the river of air that usually steers storms cleanly from west to east across the continent.
And the result is what the briefing calls a stationary frontal boundary, and it's lingering across the Northeast and the Midwest,
causing absolute chaos.
Let's look at the East Coast first. New York City is sitting at 84 degrees, which, seems relatively mild.
Sounds nice, actually.
Yeah, but they are under severe thunderstorm watches and facing overnight flash flood risks because the soils are already completely saturated from previous block storms.
Right, the ground can't take any more water.
Exactly. And if you follow that boundary south, Washington, D.C. is sitting at a very muggy 91 degrees, with places like Wilmington under active flood advisories.
And the danger there is when the soils are saturated, the ground stops acting like a sponge and starts acting like a concrete parking lot.
Oh, wow. Yeah.
Any additional rainfall instantly becomes dangerous surface runoff.
But the part of this report that really demands attention is the Midwest and the Ohio Valley. AccuWeather is forecasting 4 to 8 inches of rain along a very specific corridor.
That's a massive amount of water.
It is. From north-central Indiana straight through West Virginia. The Weather Prediction Center is actually issuing warnings about life-threatening flash floods.
Which is terrifying.
I have to admit, I'm struggling to visualize this. Like, when I hear about 4 to 8 inches of rain over a massive inland area, I immediately think of a dying hurricane blowing ashore.
Right, a tropical system.
Yeah, so how does a standard, nameless summer weather front dump tropical-level water on a landlocked state like Indiana?
Well, it all circles back to the brick wall in the south. Under normal conditions, a summer thunderstorm develops in the afternoon, it drops heavy rain for maybe an hour, and then the upper-level wind currents push it along to the next county.
The storm moves on.
Right, it moves. But right now, the southern heat dome is actively blocking those steering currents. The wind that would normally push these storm systems out into the Atlantic Ocean is just gone.
Oh, so the weather front just stalls out.
Exactly. It stalls.
It's just sitting in traffic.
It's absolutely atmospheric gridlock. And this creates a devastating phenomenon that meteorologists call training.
Training?
Yeah. If you imagine that stationary weather front as a set of train tracks drawn across the sky, the thunderstorms are the boxcars.
Oh, I see.
They develop and move along this track, one after another, in a continuous loop.
Wow. So instead of a storm ruining your afternoon picnic for an hour and then clearing up, you were getting hit repeatedly.
Over and over. A community in Indiana might get hit by a torrential downpour at 2 p.m. Then another cell rolls over the exact same neighborhood at 4 p.m.
Just compounding the problem.
Exactly. Then another at 6 p.m. The first storm fills the drainage ditches. The second storm overflows the local creeks.
And then the third one just wreaks havoc.
Right. By the time the third or fourth storm rolls over that exact same localized area, the rivers are breaching their banks and the water is pouring into basements and living rooms.
That's horrifying.
It is. And this is why we say the weather is deeply interconnected. The heat dome isn't just making Texas uncomfortable. Its stubborn immobility is the direct physical cause of life-threatening floods in West Virginia.
That is just a staggering way to look at it. The South is baking and the East is drowning because of it.
Yeah.
Let's pivot and look out west to the dry northern edges of this high-pressure system, because the jet stream being displaced doesn't just mean stalled rain in the east.
No, it has huge impacts everywhere.
It means shifted winds in the west, and it's turning the Pacific Northwest into an absolute tinderbox. We are looking at a massive continental-scale smoke crisis.
Yeah, the scale of the current fire activity is difficult to even comprehend. The National Interagency Fire Center data aggregated here, it shows nearly 2.2 million acres actively burning right now, just between Washington and Oregon.
2.2 million acres. That's hard to even picture.
It is. And to put that in perspective, that's a significant portion of the 6.4 million acres burning nationally this year.
And the human cost behind those numbers is devastating. I mean, the briefing specifically highlights the Old Trails Fire Complex in Spokane County, Washington.
Yeah, that's a bad one.
We're talking about over 700 buildings destroyed by the initial explosive outbreak of the fire. Governor Bob Ferguson has declared a full public health emergency.
It's a total disaster up there.
But what I find truly bizarre is how the atmospheric machine is choosing to distribute the fallout from these fires.
What do you mean?
Well, Seattle is sitting at a very pleasant 82 degrees today. They caught a lucky wind shift where westerly breezes off the Pacific cleared the smoke right out, pushing it entirely away from the I-5 corridor.
Right, ocean air saving the day.
Yeah. But if you look just a few hours east across the state, Spokane is at 84 degrees and completely choking on air quality deemed unhealthy to ULT. Very unhealthy.
It really illustrates how completely at the mercy of localized wind shear these communities are.
Right. So what does this all mean for the people living there? I try to picture it like an erratic chimney.
A chimney.
Yeah, you have this massive inferno producing unthinkable amounts of smoke. And the only thing deciding who gets to breathe today is the chimney draft. Seattle gets clear skies simply because the draft happened to blow the other way, while the interior of the region is just suffocating under a blanket of ash.
If we connect this to the bigger picture, that chimney smoke doesn't respect state lines.
No, it definitely doesn't.
The daily briefing tracks this massive plume of smoke moving steadily east, crossing the Rockies and spilling into the Mountain West.
Wow, it travels that far.
Oh, yeah. And this is where we witness another incredible atmospheric mechanism at play. AccuWeather notes that air quality in places like Idaho, Montana, and Wyoming is deteriorating at an alarming rate.
Because of the smoke from Washington.
Yes. Billings, Montana is sitting at 97 degrees. Casper, Wyoming is at 101. Both cities are dealing with widespread, hazardous air quality and severely reduced visibility.
See, this is confusing to me. I always learned in grade school that heat rises. If it's 100 degrees in Wyoming, why doesn't that hot surface air just carry the wildfire smoke straight up into the upper atmosphere and away from the people?
That is normally exactly what happens, and it's based on what we call the standard lapse rate.
The lapse rate, okay.
Usually, the higher you go in the troposphere, the colder the air gets. Hot, smoky air from the surface naturally wants to rise, expand into that cooler air aloft, and disperse.
Right, like a hot air balloon.
Exactly. But remember that massive high-pressure ridge we talked about? The sinking, compressing air?
The atmospheric bouncer.
Yes. On the fringes of that system, that sinking air creates a layer of warm air high above the ground that is actually hotter than the air down at the surface.
Wait, really?
Yes, it flips the normal rules of atmospheric physics completely upside down. It inverts the temperature profile.
Ah, so that is what a temperature inversion is. You have relatively cooler air trapped down in the mountain valleys with a heavy blanket of abnormally hot air sitting like a ceiling right on top of it.
It functions as a second low-altitude lid. When the wildfire smoke drifts hundreds of miles eastward from Washington and settles into the bowl-like topography of the valleys in Montana and Wyoming, it tries to rise.
But it hits the ceiling.
As soon as it hits that invisible layer of warmer air aloft, it loses all its buoyancy. The smoke just flattens out against the ceiling.
Oh, man.
It traps all those hazardous microscopic particulates right at ground level. So the residents of Billings aren't just dealing with 97-degree heat. They are essentially locked inside a smoky, poorly ventilated
It
greenhouse.
just feels relentless. I mean, when you look at these massive continent-spanning systems, right?
Yeah.
The suffocating heat dome, the stalled collision zone drowning the Midwest, the millions of acres burning and smoking out the
It's
mountains,
a lot.
it is incredibly easy to assume the entire map is just locked in a state of unmitigated chaos.
Oh, sure.
But here's where it gets really interesting, because the actual physical geography of the Earth can put up a stubborn fight against these macro trends.
Yeah, the overarching atmospheric pressure sets the baseline, certainly, but local topography and the immense thermal mass of the oceans, well, they can create astonishing anomalies that completely rewrite the local narrative.
Let's talk about those geographical superpowers, the outliers.
Okay, let's do it.
First, we have to look at California. Because when we talk about August and wildfires, California is usually the epicenter of the crisis.
Usually, yeah.
But the 2026 season has been surprisingly subdued for them. The briefing notes they've only burned about 200,000 acres through July.
Which sounds like a lot, but for them...
Right, for them it's only about 68% of their historical normal pace.
And given the intense heat parked over the interior of the state, that lower acreage is a massive bullet dodged for their emergency management agencies.
Seriously. Which leads to a statistic in this report that forced me to read it twice. San Francisco is sitting at 63 degrees today. A crisp, cool 63.
Sounds lovely.
They are wrapped up in a dense marine layer. But if you get in your car and drive less than 60 miles inland, Redding is melting at 107 degrees.
That's a brutal drive.
Fresno's hitting 105. I mean, I could pack a heavy winter parka for a morning walk in San Francisco and then literally melt my sneakers to the pavement an hour away in the Central Valley.
It's a wild contrast.
How does a 40-degree temperature swing exist across such a tiny geographic distance when both cities are technically trapped under the same high-pressure heat dome?
Well, it really comes down to a localized battle between the air and the water. San Francisco benefits from a phenomenon driven by the Pacific Ocean.
Okay.
The water off the coast of Northern California is driven by deep, cold, upwelling currents. It is freezing. When the incredibly warm, dry interior air generated by that high-pressure ridge moves offshore and hits that freezing ocean water, it cools down rapidly. The moisture condenses into a thick, low-hanging fog bank.
And that is a marine layer.
That is the marine layer.
So it's almost like a heavy, cold liquid sitting right on the coastline.
That's a great way to visualize it. Cold air is very dense, and this marine layer is incredibly heavy. It doesn't have the kinetic energy to rise very high into the atmosphere.
Oh, I see.
So it gets pulled inland through the Golden Gate, wrapping the bay in a natural 63-degree air conditioning blanket.
That sounds amazing right now.
But the moment you move inland, you run into the coastal mountain ranges.
And because that cold air is so heavy and lacks energy, it can't climb the hills. The mountains act as a physical dam holding back a reservoir of cold air.
Yes, the topography wins the battle. The mountains completely block the marine layer from progressing eastward. So while someone in San Francisco enjoys a foggy, temperate morning, the Central Valley, which is just over the crest of those hills, is completely cut off from that oceanic relief.
They just get cooked.
They get the full, unmitigated force of the sinking high-pressure heat dome. It's a perfect example of how massive planetary systems might dictate the broad strokes, but your local geography always has the final, absolute say in your daily weather experience.
It is truly fascinating to see how topography shapes our reality. And we see similar bizarre outliers elsewhere in the report, too.
Oh, yeah, definitely.
Denver is sitting at a very pleasant 77 degrees today, while just a couple hours north, Cheyenne, Wyoming, is facing 100-degree heat and critical fire weather warnings.
Another huge swing.
Even in the tropics, which you would expect to be boiling in mid-August, Florida is having a completely average day. Pensacola is at a quiet 87 degrees.
Which is pretty mild for August.
Though I should note, the National Hurricane Center, the NHC, is keeping a very close eye on the Pacific Basin right now. They're watching potential tropical cyclone 1C, which is currently threatening Hawaii.
Right. And, those outliers, they serve as an important reminder.
How so?
Well, while we tend to focus our attention on the massive, disruptive systems dominating the headlines, the atmosphere remains incredibly complex, and there will always be pockets of quiet hidden within the chaos.
It fundamentally changes how you look at a weather map. When you understand the interconnected machinery of the atmosphere, you realize that the weather outside your window is never an isolated, random event.
Right, it's all tied together.
It is always a reaction to something else. When you step outside in Wyoming and see a hazy orange sky, you don't just think, it's smoky today.
No, you know exactly why.
Right. You are looking at the remnants of a raging fire in Washington state, held down by a suffocating lid of inverted air. And when you see a horrifying flood warning pop up on your phone in Indiana, you know it's happening because a stubborn, invisible dome over Texas is refusing to let the atmosphere breathe. It's all one giant interconnected engine.
It is. And honestly, analyzing this data raises an important question, one that I think we all need to be considering as we look at the climate trends moving forward.
What's that?
We have spent this entire deep dive unpacking how stalled stationary fronts cause localized disasters simply because they are blocked by these incredibly stubborn heat domes. The heat stays put, so the rain stays put.
The traffic gridlock we talked about earlier?
Yeah, the gridlock. But if we look at the long-term meteorological trends, these upper-level ridges are growing broader and they're becoming much more persistent.
That's not a good sign.
No, it's not. If this pattern continues to escalate, what happens to our fundamental concept of passing weather?
What do you mean?
Well, we are culturally conditioned to expect a thunderstorm to roll in, drop its rain, and move on. We're used to a heat wave lasting 3 or 4 days before a brisk cold front inevitably sweeps it away.
Right, we expect the gears of the machine to keep turning.
Exactly. But what if the gears start seizing up more often? Could we be looking at a near future where weather systems don't just pass through your city anymore, but instead they set up camp and dictate your reality for weeks at a time?
Wow.
What happens to our civic infrastructure, our agriculture, and our daily lives when the weather simply stops moving?
That is a deeply chilling thought to leave on. The invisible machine isn't just turning. We might be watching it slowly seize up.
Yeah, it's something to think about.
Well, thank you for joining us on this deep dive into the Daily Tech Reader's Briefing. The next time you open up your app and look at those static numbers and little sun icons, remember to look for the massive engine running underneath them. Stay curious. Keep looking at the bigger picture, and we will catch you next time.